You guys can hear me and see me?
Yep.
Yep.
Outstanding. So it's weird because I normally work from home on Thursdays and I'm in my office, so I'm all confused. I think I'm going to have to go home after this. I think this is where we left off yesterday, right?
Yep. It is exactly where we left off yesterday.
I left it on the whiteboard, well, both because I'm lazy and I would have had to erase it to get it off the whiteboard, but also so that we could pick up right where we left off. On my other whiteboard, which you guys can't see, it's out of the frame, I made some notes for myself to make sure I don't forget too much because I want to finish up talking about the group project, what the expectations are from me, what you need to know. And then I want to move on. I want to spend at least half the time today talking about, I think I called it the future of manufacturing on the schedule. But really what I want to talk about is advanced manufacturing. It's weird because when I look at the YouTube live stream, it just shows a Sam reading something. So I'll figure out why it's not pinning me. Where am I? Gallery. Am I even here?
Yes. You want me to turn off my camera so it's just you, so you can find yourself easier?
No, but how come I can't see me? View. Speaker view. Gallery view. There I am. Usually that works. Or maybe the thing is not playing. That's why. The YouTube video is paused. It wasn't just streaming Sam. I just had paused the video. Okay. I meant to mute the video. There it is. Now it's fixed. Okay. So what again is the objective of this company that we're starting?
To sell Sterling engines and make a profit.
Okay. And the parts that we need to manufacture are the Y block, the base, the cylinder, the piston, the burner, and the burner top. We need to acquire the fasteners, the O-rings, the test tube, the box, the packing material, the steel wool. Does anybody know what this says?
Aluminum? Question mark.
Advertising?
I don't know. There may be something else that goes in that box.
Oh, Allen key. Allen key. It's an Allen key.
Allen key to go with the fasteners. That's because I don't know. I think ever since we shopped at IKEA, we expect the manufacturer to give us the tools for anything that requires assembly. Except IKEA doesn't give you screwdrivers and hammers; they just give you those crappy little Allen keys. All right. What we need to figure out then is the cost to acquire our CNC machine tools, the cost for our facility, which I think we decided that we were going to get a 5-year lease on 2,000 square feet at $7 a foot. The cost for our facility, and that cost for our facility is going to include utility bills also. So internet and electricity and heat and
That's what the $500 a month is.
that's why we added this $500 a month extra in taxes and in insurance and stuff like that. And we're going to go with 500. We're going to be optimistic, right? All right, so we need to, so we've got our CNC machine tools, our facility. We need the cost of the tooling and the tool holders that we need to make these parts, right? And so you're going to get your tool lists from the Esprit files. You still need the Esprit files for the lathe parts, because you don't have the Esprit files for the lathe parts, but you have the Esprit files for the mill parts.
What exactly is the deliverable? Just like a list of information kind of thing?
We're going to get to that.
Oh, okay.
The deliverable will be I call it a 4-page business plan, but it's really more of a 4-page sketch of a business plan or business model that you could use to convince people to give you the capital, whether they be investors, debt people, or the grants people. So this is what we think we're going to do. This is how much we think it's going to cost. This is how quickly we think we can repay the money that we need to start doing it. The cost for the tooling. We also said we probably need about $5,000 for metrology tools. Costs for that. What else? Can't even read my own handwriting now. Materials. Oh, yeah, we need the materials for the packaging. So we need the boxes, and that's on our list here. And a sales price. I think as we ended yesterday, I tasked you to go out to the internet, find other things similar to a kit where you can assemble this Sterling engine, and see what are other people charging for the thing we want to make. Is that a good method to find out what the price should be?
Yes, but it would also have to be modified to make it not only competitive, but also in a way so we can, somehow reap in money without hemorrhaging it, if that makes sense. Like there's a
difference here between the price and the cost.
Or are we referring to price as sales price and cost as in cost to us? Okay.
So the price is the amount that we're going to charge our customers to acquire the kits that we're making and shipping to them. The cost is how much it costs us to create the thing. The difference is, of course, the profit, right? Or the profit margin on each part. So what we need to do then, either in the chat or just shout it out, what are some prices? I'll make sure you get the Esprit files for the mill parts and the lathe parts. I actually had that on my list. Somebody said $1.
I found one for $25.
$25. What do you get for $25?
You get, where did it go? Hold on, I'm trying to find it.
Did anybody else look up a price?
It features an external combustion engine, a piston, it looks like it's pre-built.
All right, I got somebody says the prices range from $40 to $200. 22.30 I see, 22 to 60 I see. So when at WPI, when we started making thermoacoustic engines instead of these, I should find my spool. When I was in M1800, we made a spool. Like thread would come off of, except it was like yay tall. And it had some threaded holes in it. It had some chamfered holes. and it was made out of a casting. And it was good for putting on your desk to keep the papers from blowing away after the class was over. What's our thermoacoustic engine good for?
Showing off that we made this.
After class is over. It's good for putting on your desk and making sure that the papers don't blow away. But if you get bored, you could light the papers on fire. So I would say that ours is a little bit better. But when we got to the other thing that's better about it is there are critical dimensions and tolerances that make it work or not work. So when we first started doing this here at WPI, what we did was we found a manufacturer of kits, like I'm just talking about. And we talked to the manufacturer and we said, we want to buy your kits for our students to use. But we don't want you to finish making all the parts. We want you to only finish making some of the parts. We're going to have our students finish making the rest of the parts, and then we're going to assemble them. And those kits were, I don't know, this was 20 years ago. 20 years ago, those kits were selling for about 60, 70 bucks each. I think we negotiated $55 for them or something to get them slightly less made. It was in, I don't know, 2010 or so that we switched to the thermoacoustic engine from the Stirling engine. And that was because the company no longer wanted to sell us partially finished kits. They wanted us to either buy the full kit or not buy anything at all. And so we went to YouTube. We saw these other cool thermoacoustic engines and we decided we'd build those. So that's where we are. So I think the price is somewhere between $60 and $100 for this kit. Should we pick a price?
Not yet.
Why?
Because if we pick a price now, we could pick
See how much it costs to make.
Yeah.
Right. And so the exercise, that's the next thing on our list of things that we have to do for our business plan is we need to understand the cost to make it. Right. And so what goes into the cost of making these parts?
All the stuff we talked about yesterday.
All the stuff we talked about yesterday and
Cost of materials.
Cost of materials.
Cost of labor per part.
The cost of materials, and right, we skipped over the cost of labor yesterday.
What about
labor?
What about shop time?
We could talk about shop time, but it's not factored in what we're doing here because we already know who the employees are and we already know.
Oh, okay.
Right. So we're gonna think about it a little bit differently. A lot of times, all that overhead stuff, all the stuff that we talked about. So the cost of the machine tools, the cost of facilities, the cost of having tooling there, the cost of the QC equipment, and the cost of having a sales team, and the cost of having secretaries and paying the CEO. We put all that together. We call that the overhead. And then we figure out how many hours a day can we use our machine tools. And then we divide that overhead by the number of hours in the day or in the year or in the time period that we're talking about. And we figure that's our shop rate. And so often we'll come up with a shop rate for doing machining work like this between 60 and, I don't know, it's probably going up to around $160 an hour. So between $60 an hour at the cheap end to about $160 an hour. And that's where somebody wants to quickly estimate the cost of making a part at a job shop. They can say, all right, this part's going to be in the machine for 20 minutes at $60 an hour. That's $20 to make the part plus whatever the materials are. So that's what the question about shop rate is. We're not going to figure a shop rate directly here because we are the direct to consumer manufacturer. So we're a tier 1 manufacturer in this case. And so what we want to know, so you've got 3 employees, right? Your 3 partners that are founding the company. When you go tell the bank that you want to borrow the money, or you go tell the investors you want to get the money from them to start the company, they will not believe you if you say that we're not going to take a salary as the startup people, unless you can explain to them how you're going to feed yourself. Right? it does cost something to have you there, even if you are the co-founders. So you'll need to pick a salary that you can justify that you're going to pay yourselves. So you can justify that, my rent is, I don't know, what do rents go for in Worcester these days?
Cheaper than LA.
I don't know. I heard they're around $1,600, $1,800 a month for like a 3-bedroom for a student apartment.
What? That's so cheap.
Sounds probably like 2 to 25 for like three
Okay.
person.
I think it depends on where you get the apartment. But yeah, so really 2,500 now, huh?
For a 3-bedroom, that still seems really cheap.
Well, and if you're talking about LA or Boston, it's like half what you'd pay, right?
I was about to say
But
2,500 for 3
this
bedrooms.
is not LA or Boston. This is Worcester.
I was gonna say where I live, it's like 2,000 plus for one.
Yeah. Okay. Anyway, so you got to have a reasonable amount that you're going to pay yourselves for running the facility. And you've got that is what your cost to operate for the year is, or for the year, for the month. We've picked a sales price. Let's pick a sales price. You guys want to pick a sales price?
Shouldn't we do more math first about like cost per part?
As long as we don't pick an unreasonable sales price, we will be able to figure out how to make the parts for less than the sales price, I believe. You're right. We'd like to know what the cost is, because we're going to have to justify to the bank over here that we'll be able to make the parts. What do you guys think it cost is to make one of these? Factor in, if you just look at the materials, and if you just look at the materials cost, what do you think the cost is to make one of these?
Less than $10 each.
Or it depends
just
on
materials, pretty cheap.
It's more than $10.
it depends on like how many pieces you can get out of the stock material.
Okay, so you can find out the cost of the material, and that was,
You want us to use McMaster-Carr or whatever?
I was going to say, we're going to use McMaster-Carr to get the cost of the materials. All right, so you're going to find the cost of the materials. You're going to find the cost of the CNC machine tools, the cost of the tooling and tool holders, and what's our sales price?
Well, it's going to be our cost minus our price.
No, our profit is going to be our
Oh,
sales price minus our cost. What's our sales price? What can we sell these for?
we can sell them in the range of 60 to 100. So 80 would be in the middle of that.
What do you guys think? In the chat, type what you want the sales price to be. I'll do a quick average in my head. All right, I'm ready. $67. Plus shipping. So we will pass on the cost of shipping to our customers. All right. So you need to figure out how to get the equipment you need and the tooling you need so that you can sell these for $67 and support 3 people. Is there any other information you need?
What's the dimensions of the different types of stock that we used?
I've got a list I'm forwarding you that has all the stock dimensions.
Okay. Awesome.
So we need to feed 3 people, meaning that we're not paying them like a salary type deal, like labor.
Well, you need to, yeah, you are paying them some sort of a salary so that it's enough so that they could survive, right?
And does that?
But it could be less
founders?
than the market salary because you're owners of the company and you're expecting to make a profit later.
So is that just for the founders? Do you still have to pay your employees?
If you want to, all right, so if you decide you're going to get 600 machine tools, then you need to get more staff. So
Right.
yes, if you can't reasonably argue that the founders could run the facility, you'll need to get more staff.
Okay.
And if you need a larger facility, 2,000 square feet, I've once seen 14 machines and 1,000 square feet, but that was packed pretty tight. So I think you can go with this. So you're going to have to determine how many a year do you have to sell? How many a year can you make? So one way to do this would be to have one person operating at a time, but operating 3 shifts. So running the machines 24 hours a day, or run 3 operators at a time with 1 shift, right? So you can make those judgments.
You just lost signal?
My camera just turned off, I see.
I haven't seen a screen like that in forever.
Oh, we might be done with me on camera. I can't get the power to turn back on.
What about competition? What are other people charging to do similar things?
So that was the go out to the internet and find out what other people are charging. People found that they range between $60 and $200.
Okay.
So we picked $67. If $67 doesn't work, if you can't make the math work for $67, then argue a higher price.
I have a question.
Yes.
Are we figuring out how much we need to make to break even, or how much we need to make a profit?
You need to make enough to pay for the machine tools, to pay the rent, to pay for all the materials for what you're building, and to pay yourselves, and presumably have a profit on top of that.
Do we get to decide our profit margin?
That is the wonderful part of doing this, is you always get to decide your own profit margin. You don't always get the job, but you get to decide how much profit you want for the job. It's likely to be in the range of about 20 to 30% if you're doing a good job.
Okay.
So, Professor,
Yes.
just a question about like that monthly $500 operating cost.
Mm-hmm.
Does that utilities? Does that also go into I suppose just running the machine tools. So is the machine tools
Yeah, that's
just
power, that includes power for the machines,
okay? So
which
for
is one
the
of the reasons I think it might be a little bit light.
yeah. So it's an upfront cost for the machine tools, but then we need to. Did you say it was 3 of each tool per month, and 1 tool holder for each tool, presumably forever?
Assume that. So I said assume for each tool that you're going to have to buy 3 of them. I meant per year. But let's make that a little bit simpler. Let's assume for every 5,000 parts you need to replace each tool.
Okay. But does that include like? Okay.
So if you've got a drill, the drill will
Right.
last 5,000 parts. If you've got an end mill, it'll last 5,000 parts. And again, as you make parts, you actually learn how long the tools last. So that's the number that we're making an assumption before we've made any parts.
Okay. And it doesn't matter like which parts. It's 5,000.
Yeah,
So it's like if you do,
for the sake of this exercise, it doesn't matter which parts.
got it.
In reality, the tools that cut the brass parts are going to last a little bit longer than the tools that cut the aluminum parts. And all of those tools are going to last a whole lot longer than the tools that cut the steel parts or the titanium parts or the stainless steel parts. But since we only have aluminum and brass, that's not an issue.
Okay.
I'm
So
still
like it could
staring
cut,
at the camera when I talk.
okay, so it could cut 250 or no 2,500 like Y blocks, and then like
So if the power came back onto the camera, cool. If you're I meant 5,000 finished engines.
okay. Thank you for that clarification.
And to answer your question. So what you need are the Esprit files for all the parts to make sure that you have the same ones, and the list of stock material, O-ring sizes, test tube, and we've got a list that show the part numbers that we purchase for this. So that should be easy for you to do. Get those prices from McMaster-Carr unless it says on the list to get it from somewhere else. All right. I think that's enough. We'll have some time. So this will be due end of the week next week. We'll have some time Tuesday to answer questions again also.
And then like you want like a page, 4 pages of
No more than 4 pages,
no more than 4 pages. Okay, got it.
including any graphs or any pictures or anything that you put in.
Okay.
All right. If questions come up, email me. We'll talk again on Tuesday to answer questions, go over this stuff. I will, based on what we said here and what I wrote on the whiteboard, I will create a 1-page assignment page so there's a place to hand this in. Again, it's a group project. Do it with your group. I should have the surface roughness stuff back to you today. I didn't get finished yesterday, but I'm still working on that.
I've been writing
everything so far. It looks good.
I've been writing like notes and stuff, but could you like put like a few sentences just summarizing what the assignment is and what the deliverable
Yeah, that
is?
was what I was just saying.
Okay.
Yep.
I didn't know if that's exactly what you were saying.
Yeah. So I'll get that to you before I finish grading the surface roughness stuff today. And I think that covers it.
Professor, can you go a bit more in depth as to what you mean by metrology equipment? Do you mean like detection equipment and things like halcron or?
I mean things like calipers and micrometers and granite tables and height gauges and optical interferometers and things like that.
Okay, that's what I thought.
Yeah. Well, unless you get a used one, you won't get an interferometer in there. But yeah, because you really need a handful of micrometers, bore mics, and stuff to make these parts. There's only one critical tolerance, or the one critical tolerance that's a tight tolerance. Okay, let's move on then. If I say the words advanced manufacturing, what do you think of?
Multi-axis, like more than 3, like 4 axis, whatever, like robotic.
Axis more 3. So you mean like time axis?
Or like,
So we like you need to do advanced manufacturing if you're building a time machine?
no, more like it can do like weird like motions with the, so like if I have
in a typical turning operation in the lathe, there's 2 axes that move in the machine tool, right? So, or there's 2 directions of motion of the tool. So it goes in and out in the X direction. If this is the workpiece, the tool comes in and out in the X direction, and it moves along in the Z direction. And so typically we call that 2-axis machining. The other way we get 2-axis machining is if we've got our workpiece in the mill and we're moving a tool in these 2 directions, in the X and Y direction. Z would be this way. And now it's hard to do 2-axis machining in a mill and have it truly be 2-axis machining, right? Because you're going to get the tool down to the workpiece. But some early CNC machine tools, getting the tool down to the cutting height was a manual operation. And it was only the XY that they controlled. In the typical CNC milling machine these days, it goes XY, X, Y, and Z. So we typically, if we're cutting out something from the top down, where we're making contours around it, and we're making pockets, and we're drilling holes and things like that, we often will call that 2.5-axis machining. The Z-axis motion is almost always just for positioning the tool so that it can start cutting. A 3-axis machining move would be when we're moving up and down X, Y, and Z at the same time. Is similar to when we made the, so you did the Y block machining, right? When it goes around the outside of the part there, it's doing a 3-axis motion. It's doing a spiral down around the part. And so what you said is more than 3-axis.
Yeah,
that's when instead of just having the part move in X and Y and the tool move up and down in Z, you also can rotate the part. That would be a 4th axis while you're doing the X, Y, and Z. And you can tip the part up and rotate the part. That would be a 5-axis move then, if it was doing that. So that's what you mean. That's the first thing that comes to mind when you hear about advanced manufacturing. Right. Anybody else? What comes to mind when you hear about advanced manufacturing?
Nano machines to manufacture stuff like really small.
Sorry, I couldn't hear you.
Something like a nano machine, stuff like that. Like some
so
machines.
Nano machining. That is, as you guessed it, making stuff that's really small. We used to do micro machining, but micro machining isn't so cool anymore now that we can do nano machining. And
Bio machining? Could you like use like biocompatible materials?
biocompatible materials. So I mean, so biomanufacturing is a thing. So we're growing the thing that we're making out of some medium or something like that. So, and again, I said advanced manufacturing. I didn't say advanced machining. Machining is a manufacturing process that does material removal by large chip formation, right? But manufacturing doesn't have to be just machining. So far, I haven't heard the thing that I was expecting to hear first.
3D printing?
So 3D printing, or the cool engineering manufacturing types, manufacturing engineering types, we like to call it additive manufacturing.
Yeah.
When did additive manufacturing become a thing?
I want to say like around 2015. Like that's when I remember 3D printers got getting really popular.
Anybody else?
I want to say it's been around for a while.
Can you argue like sculpting things? Can you argue that sculpting things out of clay is additive? So like thousands of years.
So making a pot of pottery on the little spinny wheel thing by lumping down clay and then forming it to the shape you want is a form of additive manufacturing.
Ah, okay.
That wasn't the one I was thinking of, but yes, that was a good answer.
Could you say like casting iron and plastic and so on? Is that
Casting is an additive. I guess maybe we'd call casting to be a forming process.
Blacksmithing?
Casting is like its own thing. We call casting. Welding is an additive manufacturing process. And we've been doing welding, additive welding, 3D printing for a long time. One of the things you do if you accidentally machine something that you didn't mean to machine is you get out your welder and you fill the hole up with weld material, you grind it flat, and you try again. It's like the undo button on the CNC machine tool controller. It loads a welder into the spindle, and it does not do that. The undo button only changes the things you did on the computer. It doesn't change what you did in the machine tool. But what I was thinking was in the early 1980s is when they built the first STL printers. So we've been doing 3D printing since the 1980s. It became really popular sometime around when the TED conferences became really popular and people would talk about additive manufacturing on a TED Talk. But we've been doing additive manufacturing for a long time. What makes manufacturing advanced? So I said we're going to talk about advanced manufacturing. Advanced manufacturing, you hear the term all the time. If you work in a school, if you work in a mechanical engineering department at a school, you hear advanced manufacturing all the time.
It's a new type of manufacturing that has some sort of advantage over current methods.
So, all right, you say it's advanced because it's new. Anybody else?
More efficient?
You say it's advanced because it's efficient.
More complicated in some way.
Complicated.
it's really cool.
I have a friend. His nickname is Dr. Cool. He owns a manufacturing company. You know what he makes?
What?
Coolant nozzles for grinding machines.
I love that. That's wonderful.
So advanced manufacturing is new, efficient, complicated. These two probably don't go together. It's cool.
You don't need the stock like the traditional one.
Oh, so some really cool advanced manufacturing that I heard about on NPR about 3 years ago while I was waiting to make a left turn on Salisbury Street at the intersection of Park Ave and Salisbury Street. This is how cool it was. I remember at the intersection where I was when the guy talked about it on NPR. There's some researchers, now I can't remember where he worked and what school he's from, but he's a researcher. They're printing materials atom by atom to make molecules. That's really cool. Like they've got, like, it's not just atom by atom because they're creating the atoms that they need to make what they think. They can print table salt from raw material.
How?
I don't know. I was listening to a guy get interviewed on a radio show. I haven't seen it in production yet. Really cool advanced manufacturing would be able to say computer, tea, Earl Grey, hot, and then walk over and get your cup of tea, right? That would be advanced manufacturing.
So like Star Trek, or like.
Right. So advanced manufacturing as a term is a very amorphous term. It certainly often refers to new, complicated, cool, possibly efficient stuff. But it isn't a thing all by itself. Our department head here at WPI, actually, I think he had the best definition for advanced manufacturing I've ever heard. He said it's whatever the National Science Foundation is funding this year. So if nano manufacturing is exciting to the National Science Foundation this year, that's advanced manufacturing. If multi-axis machining is exciting to the National Science Foundation this year, that's advanced manufacturing. What advanced manufacturing is, and this is my personal opinion, it won't be a test question, but it's whatever companies are doing now and expect to be doing tomorrow, or they expect to be transitioning to tomorrow in order to grow their company. So it could be multi-axis machining, it could be multi-axis nano machining of biomaterials in efficient, complicated, cool ways. But so that's all right. So that's this term advanced manufacturing that people throw out there. And so if you get anything out of this part of the lecture, remember that advanced manufacturing means everything and nothing. What's the future of manufacturing then? It is different from advanced manufacturing. Is manufacturing going to go away as an industry?
No.
No.
Right. Not, at least not until we all have a Star Trek replicator, which does not have to be manufactured itself. So manufacturing is not going to go away as an industry. What's the future? Is it going to stay the same? I think we know it's not going to stay the same, right? Because people like us like to invent complicated, cool, new things and then claim that they're efficient. So what's the future of, what do you think the future of manufacturing holds? I know what I think it holds, but I want to hear from you what you think it holds. How is a manufacturing company tomorrow going to be different from one today or yesterday?
AI learning.
Incorporate more let's say, automation and artificial intelligence, then no.
All right, so
Machine learning, I feel like definitely is going to be in there.
machine learning. What's the difference between AI and machine learning? Does anybody know?
An AI is an intelligent that's like
I'm not sure anybody actually knows the difference. Different people use the terms interchangeably, but
I feel like an AI can
it
tell
always
you a
bugs me when
story.
people talk about we're developing artificial intelligence, because I think those people first need to prove that they've developed normal intelligence. But that's an aside. So, but by machine learning, we mean that we're building systems that can observe and make decisions based on the observations, and then refine their ability to make those decisions based on the results of the previous decisions. Is that what we mean by machine learning? I think it is. And I think what that machine learning, what does the machine learning do for us? I agree that machine learning is going to be a key factor in the future of manufacturing. What does machine learning get us?
It lets you have less people working.
It allows you to, it may allow you to have fewer people working, right? Because machine learning is a type of automation. And it's often automating the engineering and possibly management decisions. So it's a way to automate. We should go hang all the people that work on machine learning and artificial intelligence, right? They're trying to make our jobs go away.
Yes, maybe.
So does it necessarily, so automation can mean a lot of things. What we typically think of in automation is we typically think of those videos of the robots doing welding on car assembly lines, right? Or paint.
I can't search for videos on Apple Watch.
Well, thank you, Siri. I wasn't asking you to. But all right, cool videos, painting, all that stuff, right? That's what we usually think of as automation. But that's not the only thing automation is. What if you had, so what if you had a job shop? The first thing we remember, we talked about the job shop economics. The first thing you have to do with the job shop once the customer has sent you a drawing of a part is you've got to tell the customer how much you're going to charge them to make the part. Who does that?
You do as the job shop owner.
So an engineer does that, right? Somebody that gets paid a higher level of salary does that. If we can automate that, we can either not have as many engineers, or we could let the engineers do things that are more interesting, because spending all day long looking at parts, deciding how much they're going to cost to make is not interesting for a long time. So there's other things that you can automate besides the putting the parts in the machine, the painting the parts, the packaging the parts. I think we're at the time right now. I'll stay on for questions for a little while, but I'll go ahead and stop the YouTube. And this segues perfectly to next Tuesday, where we're going to talk about automation in manufacturing.
Professor, this is more of